Hello everyone, we continue our discussion on finding the trig functions of a right triangle. The question here is if theta is an acute angle with cosine of theta is equal to 3/4. So let's construct our triangle real quick. This is theta right here. It's a right triangle and cosine of 3/4. So 3 is on the adjacent side and 4 is on the hypotenuse. This other side we don't know, so we need to find it. So this side, which we need to find, it's called a question sign, will be equal to the square root of 4 squared minus 3 squared. That would be equal to square root of 16 minus 9, which is equal to the square root of 7. Right? That's coming from your Pythagorean theorem. That would be equal to 7. Radical 7. Okay, so let us do our sine of theta. Sine of theta is opposite over hypotenuse. That would be equal to radical 7 over 4. Cosine of theta, we already given 3/4. Tangent of theta is adjacent over hypotenuse, or opposite over adjacent, sorry. So that's going to be radical 7 over 3, right? Now, for the reciprocal functions, cosecant is the reciprocal of sine, so cosecant of theta will be 1 over your sine theta, which will flip this radical 7 over 4 to 4 over radical 7. And if we rationalize that by taking radical 7 over radical 7, we end up with 4 radical 7 over 7. The secant of theta, which is a reciprocal of cosine of theta, is 1 over cosine theta is 1 over 3/4. Flip the 3/4, it becomes 4/3. Cotangent of theta, which is the reciprocal of tan theta, we flip the radical 7 over 3, become 3 over radical 7, and then we rationalize it to get rid of the radical in the denominator. So that's over radical 7, 7 over radical 7. That would be equal to 3 radical 7 over positive 7. So there goes your trig functions for that triangle. Let's talk a bit about angle of elevation and depression. Angle of elevation and depression. Now with an angle of elevation, what we want to do is that we want to draw a horizontal line. Elevation is always looking upwards. So that's your angle of elevation right here. So theta is the angle of elevation. Angle of depression. Depression, you're always looking downwards from a horizontal. So looking downwards from a horizontal, you start at your horizontal and then you look down. So you're measuring down from a horizontal. So that's your angle of depression. Right? As depicted by our diagram right there, looking up is angle of elevation, looking down from the horizontal, angle of depression. Let's look at a couple of examples. From a point on level ground, 120 feet from the base of a tower, the angle of elevation at the top of the tower is 60 degrees. So we draw a tower. How far are we from the tower? 120 feet. So let's say 120 feet is here. You're looking up to the top of the tower. Let's say our angle, and that is 60 degrees. Let's put it a little bit closer, make the angle more realistic. Now we want to find the height of the tower. We want to find the height of the tower. So this is 120 feet from the tower. We want to find this height of the tower. What we can do then is use what we know about right triangle trig, right? So the sides I want to compare is this side, let's call it H. So H is opposite to 60 and 120 is adjacent. So we're looking at opposite side, adjacent side, that would be a perfect candidate for tan. So tan of 60 degrees is equal to H over 120. And so H would be equal to 120 times the tan of 60 degrees. And so that would be equal to 120 times the tan of 60 degrees is square root of 3. And if you want to write that in decimals, or maybe whole number, it's about 208 feet. And we're done. Right? 208 feet. Now let's look at another example. On a tree farm, palm trees are harvested when they reach a height of 20 feet. So we want the H to be 20 feet. So that's your palm tree right there. And we want to know if H is 20 feet. And so if you stand the base of the palm tree position 22 feet from the base, so that's 22 feet. And the guy who is, how tall is he? He is 6 feet tall, right? 6 feet tall. So he's 6 feet. He uses a clinometer to measure the height of the tree, and from there the angle is 30.2 degrees, so 30.2 degrees. We want to find the height of this tree. We want to find the height of this tree. So we know this distance is 22 feet, so therefore the parallel to it also has to be 22 feet. Let's call the distance from here to here, let's call it y. And so we know this distance here would be 6, from 6 to y, so let's call that 6. So we want h to be 20. So let's use a trig function here. Y is your opposite side, and 22 is your adjacent side. So we can use tan, so tan of 30.2 degrees is equal to y over 22. So y will be equal to 22 times tan of 30 degrees. All right, and so y would be equal to 12.8 feet. And now we want to know the total height. The total height is equal to y plus 6. So that's going to be 12.8 plus 6. That's going to be 18.8 feet, 0.8 feet. So it is, the tree needs to be 20 feet to harvest, so the tree is not ready to harvest. The tree is not ready to harvest. Okay, so let's look at another example. Pilot flying an airplane at an altitude of 1 mile sights something on a runway, right? So he's flying, altitude of 1 mile. So this is 1 mile. Altitude is how high he is above the ground, right? And he sights a point at the end of a runway. So there's some runway, there's a point of the runway. And the angle of depression, so the angle measuring from his horizontal side is 3 degrees, 3 degrees, okay? So this angle is 3 degrees, and if this is, let's say 90 degrees here, that means 3 from 90, you will have 87 degrees right here, okay? Now you want to find what is the distance d from the plane to the point on the runway. So d would be here. So now we know this 1 mile, we know this is d, and we know there's 87 degrees. D is on the hypotenuse, 1 mile is on the edge, adjacent to the 87. So let's use the 87 right here. So we can use cosine. So cosine of 87 degrees is equal to 1 mile over d, which is adjacent over hypotenuse. So that's 1 over d. So then d would be equal to 1 over the cosine of 87 degrees. Cosine of 87 degrees. And then if you plug that in the calculator, that would give you about 19.1. And that's 19.1, so distance is in miles. So then the plane is about 19.1 miles. 19.1 miles from that end of the runway. And that is your answer. Thanks for watching. Please remember to subscribe and see you next lesson.